Hello everyone. Today we're going to learn a new type of factoring. So we always start off with, is there a GCF? So do they all have a coefficient in common? Do they have a variable in common? If there is a GCF, you factor it out. Either way, you move on to the next step of how many terms are there. We've already done two terms, our difference of two squares. And we have done three terms when a is 1, but on today, a is not 1. So we're going to have to do not just a diamond, but also a box. So we're going to be dealing with diamond and a box today. So this part of your factoring flowchart is going to be extremely important. So make sure you have your factoring flowchart in front of you or write down some of the notes that I'm going to be going over with you today. So I want to show you kind of where it comes from. So what we've done before is we've taken a problem such as 2x plus 3 times 5x minus 1, and we've multiplied it, and we've used the box. And for a problem like this, I've already multiplied it. And if you combined our like terms, you got an answer of 10x squared plus 17x plus 3. But I want to show you a couple of things about the box that are kind of interesting. So first of all, if you were to multiply the coefficients of the diagonals, 10 times 3 is 30, and 15 times 2 is also 30. This is going to be true in every single box. The diagonals multiply to the same number. So in our problem, we can say that we're looking for two numbers that multiply to whatever a times c is, which is why on the top of our diamond we have a times c. But what we're also looking for, so this is what we're multiplying by, is what they add to. So if you take these two, the 5 and the 7, add to the 17. So we're trying to find two numbers that multiply to a times c and add to b, which is why our generic diamond problem looks like this. And this is very important when a does not equal 1. So what we're going to do is you first have to say, okay, what's a, b, and c? A is the coefficient of x squared, b is the coefficient of x, and c is the constant. Your first step is always the diamond, but for the top of the diamond, it's important that you multiply a times c. For the bottom of the diamond, it's still b, and you're looking for two numbers that multiply to whatever a times c is and add to b. Then the second step is you're going to put it into the box. So it's kind of like you're going backwards from when we just multiplied binomials. You figured out what the box was, now you need to figure out what you multiplied by. So we're going to factor out the GCF of the rows and the columns. So let's actually try this. So this first problem here, we have 3x squared plus 13x plus 4. So this is a trinomial, and a does not equal 1. A is a 3. So we're going to need a diamond, and we're going to need a box. So for the top of our diamond, we're going to go 3 times 4, which is 12. And for the bottom of our box, it's just a 13. So I have to ask myself, what two numbers multiply to 12 and add to 13? My hint for you is if they're one away, one of them is always a 1. So this is going to be 12 and 1, because 12 times 1 is 12, and 12 plus 1 is 13. Now for the box. The upper left-hand corner is always the very first term, which is 3x squared, and the bottom right corner is always the coefficient 4. We're going to take the two numbers that we just found and we're going to put them into the other two boxes with x's. So this is going to be a 12x and a 1x. Now to finish this, we are going to factor out the GCF of the rows and columns. So if I look at my first column, 3 and 12 have a 3 in common. X squared and x has an x in common. For the second column, they don't have a variable in common, and 1 and 4 has nothing, so it's just a 1. For the first row, 3x squared and 1x has an x in common. It doesn't have a number other than a 1. And 12x and 4 has a 4 in common. So if you look at the outside, that means that we multiplied 3x plus 1 by x plus 4. And that is your factored answer for problem number 1. Let's try two more of them. Okay, problem number 2. Our coefficient of Our trinomial is not a 1. There is not a GCF. I should have looked for that first. There is no GCF. Today's assignment, you will not be finding any GCFs. So for the top of my diamond problem, it is 8 times negative 9, don't lose your negatives, which is a negative 72, and the bottom is 6. So I have to think of what multiplies to negative 72 and adds to 6. So one thing about these is if it's going to multiply to a negative, one of your numbers is negative and one of them's positive. If it adds to a positive 6, that means that the positive has to be bigger. So if I'm thinking of two numbers that multiply to 72, if I wanted to, I could start doing my factorizations, my prime factorization. I happen to know this one. It is 12 and 6, because 12 times 6 is 72. If I want those two numbers to add to a positive 6, my 12 has to be the bigger number, and the 6 is my negative. So the 12 is positive. So in the upper left-hand corner of my box is the x squared term, so 8x squared. Bottom right is always the constant, negative 9. Now the two numbers that I found are negative 6, I'm going to put an x, and 12 with an x. It's also important to note that if you had put your 12 and negative 6 in opposite boxes, it's the same problem. So do not worry about which direction or which order those two go into. Okay, the GCFs. The GCF of the first column, they are both multiples of 2 and they have an x. The last column, they're both multiples of 3. Remember, we're looking for the highest GCF. For the row, the highest multiple is a 4, and they have an x in common. And on the bottom, they have a negative in common and a 3. So my answer is 2x plus 3 and 4x minus 3. So we've just factored that trinomial. Okay, we're going to try one more problem, number 3. This problem is 6x squared minus 29x plus 35. There is no GCF. There are 3 terms. The coefficient of x squared is not a 1. Therefore, it is a diamond and a box. So if I were to multiply 6 times 35, that is 210. Do not worry about that right now. I will kind of go through how to deal with such large numbers. The bottom is negative 29. Now, if you think of the numbers in terms of positives and negatives, if I'm multiplying to a positive but adding to a negative, that means they both have to be negative, because a negative times a negative is a positive. Now 210, if I didn't know what multiplied to 210, I could start my factorization tree. So I'm going to start off with 21 and 10. Do 21 and 10 add to 29? No, I got to keep going. 7 and 3, 2 and 5 for 10. So for my prime factorization, I have 7 times 3 times 2 times 5. So let's say I wanted to put them in a slightly different order. So let's just say I put these two together. That is a 6, and these two together is a 35. Is 6 plus 35 29? No. Okay, so I put it together. Let's try to put it together in a different order. How if I put together the 3 and the 5? 3 times 5 is 15, and the 7 and the 2, which is 14. Are 14 plus 15 29? Yes. So if you put together pieces, because I know that 210 is 7 times 3 times 2 times 5, if you start just putting together pieces, you can figure out other numbers that multiply. So I put the 3 and the 5 together, which was 15, and the 7 and the 2 together, which is 14, and 15 times 14 is 210, and negative 15 and negative 14 add to negative 29. So prime factorization, very handy, very useful. Okay, back to my box. Upper left-hand corner is 6x squared. Bottom right is 35. My two numbers I found, I'm going to add x's with them because those are the numbers that add to that negative 29x in the middle. Now if I take the GCF of the rows and columns, so the first column has a 3 and an x in common. The last column has a 7. The top row has a 2 and an x in common, and the bottom row has a 5. Now there's one extra thing about this, because if you look at what I've just factored out, I don't have any negatives, but inside the box there are negatives. Now the only way that you can have negatives like that is if both the 5 and the 7 are negative, because a negative times a negative is a positive, which is how that 35 is positive, and still leaves both of these as negative. So be careful with your negatives also. So our answer is 3x minus 7 times 2x minus 5. So this problem takes a little bit more effort. Your assignment only has 6 problems for today. You do have 3 days worth of assignments for these types of problems because I want you to practice these and be really good at them. So your word of the day is product, because we are dealing with a lot of products, especially A times C being the very top of your diamond. And your assignment is factoring trinomials where A does not equal 1, part 1. If you have any questions, email me, come to virtual office hours on Wednesday or Thursday, message me somehow. Do not forget to get your attendance in by Friday morning, which means you have turned in an assignment, you've emailed me, you've messaged me, you've given me some aspect to know that you still exist. Okay, if you have any questions, let me know. Have a great day.